Welcome to Study Loop.
So to solve this problem, we need to use the sinusoidal varying of electric field. So we can say the electric field is equal to the maximum electric field, M, times sine of kx minus omega t. We can say that here the propagation constant k would be equal to 2 pi times v over c, the speed of light, and v would of course be the frequency of the oscillations. So we can say here v we know to be 4.0 times 10 to the 14th hertz, and we know that for part A rather, at point P, E sub y, the y component of the electric field, would be equal to the maximum electric field divided by 4 at t equaling 0. So this is initial, and we then say that here we could substitute this into the sinusoidal varying of the electric field. This would be e to the e sub m over 4 would equal e m sine of kx minus omega t. And we know that t here is going to be 0, so this term is eliminated. We can eliminate the maximum electric field term, and we find that here the x position would be equal to 1 over the propagation constant times arc sine of 1 over 4. And so we can then solve and say x sub p would be equal to c, the speed of light, divided by 2 pi times the frequency of oscillations times, again, arc sine of 1 over 4, and we can solve. So this would be equal to we can round to 3 times 10 to the 8th meters per second divided by 2 pi times the frequency of oscillations, 4.0 times 10 to the 14th hertz. This would be to the 8th. And we would then say this would be arc sine rather, of 0.25. And we find that this is equaling 30.0 nanometers. So we can say that here, the x position here would be equal to 30 nanometers. For part B, along the positive direction, we can say that E equals 0 at 1/2 wavelength from the previous point where E equals 0. So we can say x is equaling lambda over 2. This is going to be equal to the speed of light divided by 2 times the frequency. And we can then solve. This would be 3 times 10 to the 8th meters per second divided by 2 times the frequency, 4.0 times 10 to the 14th hertz. And here, x will be equal to 375 nanometers. Now, the distance from the point E equals 0 to a point P in a positive x direction, here we can say x minus x sub p would be equal to 375 minus the answer that we found in part A, minus 30. And this is equaling 345 nanometers. So this would be the answer to part B. That is the end of the solution. Thank you for watching.